Bismillahirrahmanirrahim. Welcome you all to the hands related to the assignment number 1 given on the portal. You can use this video for the solution of the two questions given. That is, you have to calculate the relative humidity using the wet bulb and the dry bulb thermometer readings that are given, that the dry bulb thermometer at 24 degrees centigrade as well as the wet bulb thermometer given, that is the 20 degrees centigrade. And the second part of the assignment, that you have to calculate the relative humidity by using the wet and dry bulb thermometer difference, that is kept 3 degrees centigrade, and again the reading of the wet bulb thermometer is given 15 degrees centigrade. Then you have to calculate using this video. You can see the chart that is also attached with the assignment number 1 on the portal link. That's the additional file. You can download this one in order to solve and calculate the relative humidity. But before going to the calculation, first of all I would like to tell you about the relative humidity, and what is meant by the relative humidity. As you know that relative humidity of air, that is abbreviated as RH, relative humidity, air at a given temperature is capable of taking up water vapor until it is saturated at 100% relative humidity. The water vapor will be taken at by the air until it is completely saturated. It means that complete saturation means that complete water vapor is taken up, and in that case when the water vapor is maximum and the air is saturated and the moisture is gains, and that is termed as it is at 100% relative humidity. It is a sample solution of water and air that follows the rules of most solutions, such as increased solubility with increased temperature, maximum solubility at a particular temperature, that is saturation, and similar example of precipitation of solute and cooling, that is condensation, like in rain. If the temperature is raised, then the air will be able to take up more moisture, because temperature increasing, well, definitely it means that moisture level will be minimum over there, and the relative humidity falls. After increasing the temperature, the relative humidity will be decreased from 100% because of the increasing temperature. This is because the percentage relative humidity may be defined as vapor pressure of water vapor in the air. If complete saturation, it means the relative humidity will be 100%, and if we divide the vapor pressure of water vapor in the air by the vapor pressure of water vapor in air saturated at the same temperature, the temperature is kept same, and we take the vapor pressure of water in the air and then vapor pressure of water vapor and air saturated and multiply by 100 in order to get the percentage relative humidity. This is approximately equal to the percentage saturation, which is the ratio. What is meant by the percentage saturation? That is mass of vapor present per kg of dry air. If we have taken 1 kg of dry air and that particular mass of vapor present, and then 1 kg of the dry air, and they divided by the mass of vapor required to saturate 1 kg of air at the same temperature. It means that the dry air will having the maximum capacity that is the mass of paper required to saturate that particular mass which you have taken in the first, that is 1 kg, 1 kg of air capacity required vapors, and multiply by 100, that is percentage saturation. This relationship shows that the relative humidity of air is dependent not only the amount of moisture in the air but also on its temperature, as the amount of water required to saturate air is itself dependent on temperature. It should be noted that in convective drying, where warm air is passed over the surface of wet solid, the relative humidity may rise during the drying process of air of two separate factors. Now we have to note that what is meant by that factors, that relative humidity depend upon the factors, that is amount of moisture in the air and also as well as the temperature of the air. The more the temperature means the moisture will be low and the capacity to take the moisture by the air will be more, chances will be more. It should be noted that air and the convective drying, where warm air is passed over the surface of a wet solid, the relative humidity may rise during the drying process as a result of two separate factors. The first one is uptake of evaporated water vapor from the wet solid. The second one is the cooling of the supply air as it transfers heat to the water solid, that is evaporative cooling. If the cooling is excessive, the temperature of the air may fall to a value known as the dew point, when liquid water will condense and deposited, and that point is termed as dew point. Now what is meant by the relative humidity, that I have told you, that the equation regarding the relative humidity. Now we will discuss that what is the wet bulb and the dry bulb temperature. If two similar thermometers are set up, one with its bulb kept moist by a wet cotton wick immersed in a water reservoir. We have kept one that is in the water reservoir, one of the thermometer is kept in the water reservoir, and the second one is kept as such without immersing it into moist wet cotton water reservoir. The wet bulb thermometer will register a lower temperature than a dry bulb neighbor. We have kept two thermometers. One we have kept in the moist, keeping it in moist wet cotton wick, and then this cotton wick is further immersed in a depth in a water reservoir, that is the wet bulb thermometer, while with the second one that we have kept, that is the dry bulb thermometer. This is due to the evaporative cooling. The wet bulb thermometer will register a lower temperature. Why it will be kept a lower temperature? Because of the several reason. You can see that the one that is the wet bulb thermometer, it will register the lower temperature. The temperature noted in the wet bulb thermometer will be lower compared to the dry bulb one. We noted that is 40 degrees centigrade, and the second one that is without moistening and to the muslin wick soaking, and further in the water reservoir, the temperature of that particular wet one will be lower compared to the dry bulb. That is the wet bulb one that is kept in the water reservoir. This is due to the evaporative cooling, as the latent heat of evaporation is taken up from the sensible heat of water surrounding the bulb. Surrounding the bulb, that is taken that temperature, and a similar way the temperature of wet solid is kept low while free water remains, but rises toward the temperature of the drying air. as drying proceeds. Fortunately, many material can withstand higher temperature when at dry state. The two temperature will be the same only when the relative humidity is 100%. As under this condition, there will be no net evaporation of water from the sleeve. In fact, the relationship between dry bulb temperature and the depression of the wet bulb temperature as a result of evaporation is so precise that these readings can be used to calculate the percentage relative humidity of air with some accuracy. That is the description about the relative humidity and the wet bulb and dry bulb temperature. Now we have to keep the readings that is given. You can use this one example as well as the chart for the solution of the assignment number 1 that is uploaded on the portal. You will use this chart. You can see on the left side one of the example given for this purpose. We have two thermometers. One is dry bulb thermometers, that is without soaking in the water reservoir, and the second one that is the wet bulb thermometer, that is kept in the water reservoir. And temperature of the wet bulb will be lower compared to the dry bulb, and the dry bulb is 30 degrees centigrade but the wet bulb is 20 degrees centigrade. You can see the difference between the two in the chart. That is 30 minus 20 degrees centigrade, 10 degrees centigrade is the difference. Now we have to calculate the humidity, that is the relative humidity. Now by using this chart, you can see the dry bulb temperature on the left side, that is 30 is the last one. First I will point this one, that is the 30, and then on the right side you can see the difference between the wet bulb and dry bulb temperature in degrees centigrade. And as the difference is 10, I will put the mark over here that under the 10 the line will collide with the 30, that is 39. So this is the reading we will use. I am going to point out that what first we have noted the dry bulb. You can see that is a dry bulb temperature in degrees Celsius, as it is noted as 30 degrees Celsius, and then the difference I will consult over here from 0 markation to 15. The difference is 10. I will keep over here that this line will coincide with the 30 at that position, and that reading is noted, that is 39. So the 39% is the relative humidity of that particular example. And the readings, similarly you will solve these two problems. And the first one, that is the difference is given as well as the dry bulb and wet bulb thermometer, and the second one also the difference is given as well as the wet bulb thermometer. Using this wet bulb thermometer you can calculate the dry bulb thermometer as the difference is given by using the difference, that how much the difference is there, and I have told you that the dry bulb thermometer will be more compared to the wet bulb thermometer. Thank you all for your attention.